For question 14, we have the inverse Laplace of 1 over s squared minus 8s plus 17. So if you look at that denominator, s squared minus 8s plus 17 does not factor. You would have to have factors of 17 that would add to give you 8. And 17 is a prime number. Its only factors are 1 and 17. So what we're going to do is rewrite this denominator. I'm going to take those first two terms and I'm going to complete the square. So I have s squared minus 8s. To complete the square with s squared minus 8s, you would add 1/2 of the coefficient of that middle term, the negative 8 squared. So 1/2 of negative 8 is negative 4, and negative 4 squared is 16. We're going to add 16 to s squared minus 8s. So add 16. And I have 17 here, so that means I have 1 left over. I'm going to group these. And when you complete the square with this s squared minus 8s plus 16 that I have, you form a perfect square that this can factor now into s minus 4 squared. So back to my inverse Laplace transform, s squared minus 8s plus 16 is s minus 4 squared, and then I have plus 1. And 1 itself is squared. So now you want to think, well, I have a shift. That's my first shifting theorem, the Laplace of e to the at times f of t gives me the Laplace of f of t, but then I have a shift. S was shifted to s minus a. In this case, a is 4 because we have a shift of s minus 4. So I can work this backwards, and when I work it backwards, it's going to give me my exponential function. It's going to give me e to the at, a is 4, e to the 4t times the inverse Laplace, and now I can take away that shift, and I have 1 over s squared plus 1 squared. So there, with the sum of squares in the denominator, you want to think sine and cosine, and it's the sine that has a constant at the top, and then s squared plus a squared at the bottom. So the Laplace of sine of at is a over s squared plus a squared. Here, now a is 1 for that formula, and notice you have the 1 at the top. So this is e to the 4t times sine of 1t. We're just e to the 4t sine t.